this video we are going to discuss about the multipliers. On completion of this topic, the students will be able to find out the partial product generation and the 4-bit array multiplier and explain it. In multiplier, these multipliers are widely used in the digital signal processing, and also generally it is mostly more used in the general purpose workloads. That is, it contains the major categories of two types. One is signed multiplier types and another one is unsigned multipliers. It is very useful in the sign magnitude, that is sign 2's complement or sin 2's complement, very useful for fixed points of 2's complement data. If multiplicand and multiplier is multiplied, we will be getting the partial products and finally we will be producing the output. Here the naming conversation somewhat uncomfortable is multiplicand and multiplier. See, for example, 4-bit unsigned multiplicand, which is 8 times 4-bit the multiplier of b. So this b could be signed or unsigned. So this we can write it as if we consider the above term as a and the multiplicand as a and multiplier as b, this product will be equal to multiplicand into multiplier, that is a into b, or we can say a and b. So this 4-bit signed 2's complement multiplier 8 times 4-bit multiplier b means this partial product will give us p is equal to a into b or a and b. So here you can see the array multiplier. So major steps is first this generation of the partial products. Next we can reduce or we can compress the partial product so that the product is composed of two parts. One is a linear array and tree addition. And next we can add to the final adder, which is we call it as carry propagate adder. So this carry propagate adder is nothing but it converts the product into the carry save from one single form. So here you can see the array multiplier. In this array multiplier, this input, that is half adder and the full adder which we are giving is, this can be a possible partial products, and also this copies of the multiplicand and the multipliers produces the number of partial products. So one half adder, full adder, next full adder and half adder, which may give rise to another partial products, and finally the outputs will be, if you are giving the input as 0 and or it is a 4 times of the array multiplier, then we will be getting the partial outputs here. And in this m cross n array multiplier, the first thing is it is the simplest method for generating the partial product, and also it produces the 1-bit multiplier, and this partial products will produces the copies of both the multiplicand as well as the multiplier. This number of bits which we are using here contains the partial products in terms of words, or it can be a words of rows. So finally this critical path is 1 and 2, or both it can be 1 and 2. So finally we can write this as t multiplicand is equal to m minus 1 plus n minus 2 t carry plus n minus 1 t sum plus n minus 1 t and next is carry save multiplier. So this carry save multiplier is nothing but this half adder is given to the full adder. So finally partial products can be added, and finally it can be merged to an finally the partial products are merged into an adder. So t multiplicand is equal to n minus 1 t carry plus n minus 1 t and plus t merge, because the partial products are first they are merged and then added. And next one is multiplier floor plan. So multiplier floor plan, here also it consists of the partial possible output. Two reasonable hardware solutions of row of 2:1 maxes produces one multiplier cell, that is half adder multiplier cell, next full adder cell. Next these two half adder multiplier cells and full adder multiplier cells are merged. Next these two signals are broadcasted into a adder. Finally the completed array is formed. So this is the main miniature floor plan. And Wallace tree multiplier is nothing but this multiplier is contains a 4-bit sign to complement multiplicand, and it is 1100 times greater than the 4-bit multiplier. So first partial products. Next, it goes to the first stages. The bit positions are changed. So full adder and half adder are merged and finally added in the final adder. So this is the structure of the Wallace tree multiplier. So you can see here the partial outputs. These partial outputs are finally, first it is given to the half adders, next it is given to the full adders. Finally, both are merged and added in the final adder. And this is the structure of the Ace trees multiplier. So here also the carry is taken to the next step of the partial outputs. So in the multipliers, the main summary is it identifies the critical paths, and it also contains other possible techniques such as data encoding, logarithmic, uh, that is Wallace tree multiplier, and pipelining. Quiz questions on multipliers. How carry save multiplier differs from array multiplier? Thank you.